I'm Ross Albritton, Industry Mobilization Manager for American Institute of Steel Construction. Today we're here to celebrate Steel Day. Steel Day is the day that has been created to celebrate the structural steel industry nationwide. It is made up of producers, fabricators, designers, students. Anyone can be involved, people like you and I, to celebrate the structural steel industry and what it has provided for us throughout the history of our country. The following video will give you a glimpse to the inside of our industry. It will show you the process from production through planning and design to the actual fabricated building and give you some examples of each. If you haven't had an opportunity to get through a fabricator's shop or to see steel actually being milled and produced, this is our entry into understanding our industry. Designers have known for years that structural steel gives them flexibility, sustainability, adaptability, one of the strongest materials and most recycled on the face of the planet.
My focus is on the structural system, so my goal was to help create a structural system that was light and expressive and open and told a story about how the forces worked in the building, but without drawing undue attention to itself. I think steel was really the only possible structural solution given the kind of openness the architects desired. Obviously wood or concrete are conventional possibilities, but both of those would have limited the openness, limited the spans, made the size of members bulkier and heavier. It would have been a very different building had it been in concrete. Once the basic systems are established, I've done my quick calculations to check that everything will work, and we think it's solid and the design moves forward. There comes a point in the design where I go away as a structural engineer and now I have to really design it, and that means every piece and part needs to be sized. Is it a 1/4 inch plate? Is it an inch thick plate? Is it 16 inches deep? Is it 20 inches deep? What we typically do is at some point we usually construct what we call an analysis model. It's essentially just a mathematical representation of all the beams and columns and plates and so forth in the structure, and then we can apply loads to it, we can see how much it deflects, we can see what the stresses and members are. And nowadays those mathematical models have nice graphical interfaces so we can actually see the building move, we can see the stresses in it.
There's no other material that really gives us the flexibility from a structural standpoint as steel. It allows us to be very expressive in the way that we put buildings together. We design sustainable buildings, and we like for the building to express that sustainability. And steel, unlike any other material, you can get such a high recycled content in steel that you can directly tell a story about where the steel came from and create new functional buildings out of it.
It's also easier to change or make additions when you use steel, because steel is more adaptable. It gives designers and architects a tremendous advantage in meeting with the owner's requirements.
We like to think ahead for future flexibility because some of the occupants, like at universities, they know they're building a science building, but they might know in a few years that science is going to be different than it is now, so they need to be able to upgrade it. And there's a lot more recognized knowns with the steel. The structure's up there, someone can go look at the ceiling and see if they need to core new holes. They're not going to hit an important structural member. So a lot of the university work I've been working on recently, we tend to use steel because they have unusual configurations, some long span conditions, and we really think the owner benefits from this, knowing what the structure is and having flexibility, so they can work with the building over the lifetime of the building.
Steel is a main component of the structural systems for high-rise buildings, and being the type of buildings we emphasize, we work mostly in our office. We use them throughout all of our projects, both for reinforcement, for primary lateral systems, for the gravity systems in the buildings, and also for a lot more complex geometries in a lot of the buildings. Steel has great qualities and is preferable for a lot of components in the building. A lot of the buildings, tall buildings that we do, require both primary and secondary systems, where concrete is used more for the gravity systems, while other materials are used for the shear systems. And we prefer them for those. We prefer them for their quick erectability, their flexibility. We prefer them for buildings for more complex geometries. These are actually a great material.
It was really important to the university, and it became important to the design that we created a space that was collaborative and we created a kind of an architectural expression that was, enhanced learning. What is important and unique, and I think it's the challenge of the structural system, is to integrate it into the architecture. I don't think that we ever started the process and thought about it as being, something that was, kind of a background element. We always thought about the structure as being an expressive part of the architectural expression.
Steel has been produced for over a century in this country. Integrated steel mills took raw materials to produce iron, then to steel. Today, we have mini mills, but don't let the name fool you. Today's steel mini mills have capacities far beyond what the earlier integrated mills had. From the melt shop where the materials are liquefied, to the rolling mills that shape the steel. Recycled scrap can include cars, appliances, reclaimed steel, any scrap with iron or steel stock that are used to make steel.
Steel can be reused over and over again. I know that structural steel shapes are a lot stronger than what they used to be, so there's less tonnage that's required for a project. And so if there's less tonnage, there's less construction debris. If there's less construction debris, there's less waste that's generated.
The fabrication process starts for us when we receive a set of design drawings from the owner or from a design firm who has been hired by the owner. Once we receive those drawings, we prepare a set of shop drawings, and each piece is shown on a shop drawing in great detail. It shows holes, dimensions, copes, cuts, everything you need to fabricate that piece, and most of the dimensions are controlled down to a 1/16 of an inch.
Steel fabricators take the shapes and cut them to the required lengths. Connections can be programmed, drilled, cut, and prepped, and then transported to the next step. In fact, steel fabricators detail, cut, drill, and weld steel to the highest quality standards in fabrication shops throughout America to meet specific design requirements on each project.
The initial step in the erection process is the delivery and the staging of material.
Obviously, anything that gets started with planning. Planning for this site was done many months ago, even from the erection standpoint. At that particular moment, we work on what is known as sequencing. Sequencing is when we actually take, as you can see, it's many pieces involved in even this site, and we break it down into a smaller, manageable loads as far as shipping, manageable as far as lay down, and just site logistics as far as being able to identify and even find the pieces in which we want.
The next time you look at a structure, think about steel. Chances are the drama that you're feeling comes from the men and women involved in the structural steel industry, shaping it, driving it, building it, making it part of what is distinctly American-made. Steel proud means many things. It means leading the construction industry in meeting America's need for new buildings and bridges, using advanced technology, computer modeling, and American expertise. Steel proud means doing the detailing, cutting, welding to high-quality standards in fabrication shops throughout America. Steel proud means producing the steel in mills in the United States by American workers. I'm Ross Albritton, Industry Mobilization Manager for the American Institute of Steel Construction. I am proud to work in the 21st century structural steel industry. Steel proud. Thanks for viewing our video. We appreciate your time and celebrating Steel Day with us this year.